Okay, this question asks you to consider the three-dimensional representation of CCl4, Ni3, PBr5, SF4, and SF6. So you do need to know how to draw the Lewis structures. And I've drawn the Lewis structures here for all of these molecules. And if you still having problems with Lewis structures, then get with your professor, get with your instructor, and figure out how to remediate that issue, because you really do have to be able to draw the Lewis structure here. Once you've drawn the Lewis structure, then you have to examine the Lewis structure and consider what the geometries are. The geometries then can be represented in three dimensions. In the first example, CCl4, I can see that it's tetrahedral geometry. And so when I draw the structure in three dimensions, it looks like this. So two of the bonds are in the plane of the page. One comes back, one comes forward. We use wedges and dashes to represent forward and backwards. The wedge coming forward, and then dash, the squiggly line, that's going back. Okay, so the next one is Ni3. It's also got a tetrahedral electron geometry, but the molecular geometry is trigonal pyramidal. So it's going to look the same as the one before, but instead of having a bond that goes up, it's just going to be a lone pair. So this is the three-dimensional representation for that one. Okay, PBr5. Now, we don't typically deal with things that are trigonal, bipyramidal, or octahedral in organic chemistry, not too often. But in this first bit, we want you to be able to remember those things so you can think about how to draw molecules in 3D. So a trigonal bipyramidal molecule looks like this. So you have three bonds that are in plane and one that goes forward and one that goes backwards. So this is the proper representation in three dimensions for PBr5. Now for SF4, it's still trigonal bipyramidal electron geometry, but the molecular geometry is C-Sol. So when I draw that and replace one of the bonds with a lone pair, I have to pick the right bond in this case. And when I say right bond, I mean the correct bond. And so it looks like this. So I end up with the bond that is in plane along the equator. That's the one that gets the lone pair. And this is where that C-Sol geometry comes in at. Finally, the SF6, that's octahedral. And so drawing octahedral looks like that. Two bonds going back, two bonds going forward, two bonds in plane. And that's it for this question. Okay.